All right, so we've already determined what the best case running time is here, and the point of this, the key that I want to drive home, is that when I ask this question, when I ask question number 3, there's actually more than one answer to this question. So rather than just having one monolithic t of n, I really need to have a couple different t of n's, right? And so I really need to have, say, a t best of n. And t best of n, we showed in the last video, is just equal to 1. Right? So this is fast. And this just means that regardless of how large an input I give, if the first two elements are the same, then it returns very fast. Right? It returns in just one, it does one comparison and then it's done. All right, so what's the other extreme? The other extreme is t worst of n. Right? So what is t worst? And I'll just write a w to make it very clear. What is t worst of n? Right, for our worst case. Well, let's think about how we could kind of feed this thing an input that for any n maximizes the number of comparisons that have to be made. And so to do that, let me run back to the pseudocode, just so that you have that in front of you. So we want to maximize the number of comparisons that are made as we run this algorithm. How do we do that? Well, we try to maximize the number of loops that go. How do we do that? We make sure that we never return. So worst case, never return false. Right? And how do you do that? You want to make sure that this code never executes, which means you want to make the comparison operation fail every time, which means that you want all the elements to be distinct. Okay. So let's go back down to our little analysis block here. And let's say the worst case, and so I have to describe the kind of input that causes a worst case running time. So a worst case input is one with unique elements. Or I can just very simply say it's one that returns true, right? Worst case input, all distinct elements. Okay, and so now whenever you specify a worst case or best case running time, it's very important to say here's what input would cause that running time. And so for the best case, what input causes that running time? Well, it's for A0 to be equal to A1. Okay, that's a best case input, right? What's a worst case input? It's for AI to be different from AJ, that's a J, for all I and J that are not equal, right? So for all I and J such that I does not equal J, right? There's the sort of formal way of saying this is our characterization of a worst case input. So what actually happens when you run this thing on a worst case input? Well, we have two for loops that are nested, and whenever you have for loops that are nested, you can use a summation or a sequence of summations to capture directly what the running time is. Okay, so I will let you refer to the algorithm yourself, but we can end up with the following. So our outer for loop is this summation. So I starts at 0 and goes up to n minus 2. Our inner summation starts at, so j equals I plus 1 and goes up to n minus 1. And then every time that inner loop ticks, right, every iteration of the inner loop, we get one comparison. So this expression right here is the summation, right? This is the mathematical expression for the worst case number of comparisons for this algorithm. And so, we could go through the full analysis of this, and I will for you in office hours if you like. But if I were to simplify this thing down, what I would arrive at in the end is the following: 1/2 n times n minus 1. Which, if I simplify this even further, I get n squared divided by 2 minus n divided by 2. And what's the running time here? That's big theta of n squared, or that's the order of growth. So this is big theta of n squared. Right? And there's our answer, right there. So our worst case running time is quadratic in the length of the input. And this is what you would expect, given the fact that we have two nested for loops. Or if you like, the fact that we have this sort of triangle shape of calls, of the way this goes. So in the next lecture, we're going to ask, is there something else in between? But for now, what we have is, our question number 3 here is we have two answers, right? And the answer depends on what the input looks like. So t best of n is just 1, or I could write big theta of 1, right? It doesn't depend on the size of the input. And then t worst of n is big theta of n squared. Okay, so here's, these are two extremes. The question is, what goes here? Right, and that's what we'll address next time.